Okay, in this video I'm going to go through, I'm going to say maybe some graphing questions. We'll look at some multiple choice questions, we'll look at addition of ordinates, and we'll also look at graphs of reciprocal functions. A lot of the time these are maybe just one multiple choice question. Some years though they've been up to 3, 4, 5 marks on an exam 1 question. So here's an exam 1 question, and first of all, pretty straightforward. We don't have a calculator, but what you needed to realise is that if I take out, 36 over 2x squared minus 18, if I take 2 out as a common factor below, that is 36 on 2 x squared minus 9, which is equal to 18 over x squared minus 9, which is equal to 18 over x minus 3, x plus 3. Now, if you think about it, what we want to do though is when we're sketching a reciprocal function, I want you to sketch this function here. Okay, and that function here is, let's just say this after we've done some little changes there. So what is the graph of x squared, of x squared minus 9 look like? We know that it's going to look like this. And its turning point is going to be there, and we have intercepts at 3 and minus 3. So I guess this is how we want you to be able to draw these graphs, is you are actually sort of getting an idea, well, what's the reciprocal of that graph? What is the reciprocal of that graph is what we want to know. So the reciprocal of that graph, well, if it's a reciprocal of that graph, then therefore the intercepts of that are going to be asymptotes. So we have an asymptote at x equals minus 3, and we have an asymptote at x equals 3. Now, you don't have to go to this length, but that's how, maybe you should do it in like grey lead first, and then sort of rub it out, and then do, because that does help you. So I don't have a grey lead here, so I certainly don't want this to confuse you here, but doing that in grey lead is something that I would recommend. So okay, so let's just pretend I've got a grey lead. I can now rub that out. The reciprocal, well, what we know is that 1 over negative 9 is the turning point here. What that's going to represent a turning point on the graph as well. Would you agree? So now what about having a look at these values here? 1 over 0 is going to be, 1 over close to 0 is going to be infinity. So as it turns out, or negative infinity, so let's have a look. We're going to have a graph that goes this way, and it has a turning point there, and it goes down like so. Now if I... Yeah, that's right, yeah. My bad. So yes, that's right. So that's to give you the shape, but rather than this be negative 9, this is, what were you saying? Negative 1 on 9. So it's ideal to get the turning point right. So that's to give us the shape. Okay? Now let's think about this now. What about values which are greater than 3? You could just throw it in here and get an idea. So what about values which are greater than 3? So let's say if I pick 5. 5 squared is 25, 50 minus, so it's positive, and so values of greater than 3 are positive. What about really, like very, very small values, or close to 3? What's that going to be? The bottom here. Let's think about that. 3 squared is 9. 9 times 2, 18 minus 18. So let's just talk about a value so close to 3 that it's virtually, let's say 3.00000001 minus, so if I was to put that value in there, what am I going to have? I'm going to have a very, very small number on the bottom, or a very, very big number on the bottom? Very, very small number. So what's the graph going to look like? We're going to be approaching from infinity, aren't we? So we're coming up this way. Now what about as my values get really, really large? What's happening? As my x value approaches infinity, I'm going to get a really, really large number on the bottom. So what am I going to approach? I'm going to approach 0, aren't I? Okay, so that shape, despite the fact that you don't have your calculator, that's how I would get that shape. All right? And we know that that the same thing happens over this side, and this just comes with practice. Okay, so, but that's how I would work out the shape, because I don't know what a lot of these graphs look like. I just sort of think about them and look at and pick a few points out. So as it turns out, our shape comes something like this. How do you get the marks? Well, the marks are definitely 1 mark for the shape. Sorry.
Because now we're times it by 18, because that's 1 x squared minus 9.
Okay, so what do I got to change?
Because the dilation
Yep. So what have I done wrong?
So you have to make 1, right? So
That's this one here.
Yeah.
Yep.
That has to be negative 2 because you have to multiply that by 18.
Okay.
Because you've got the whole thing, it's the same as 18 times 1 on x squared minus 9.
Good, good. So thank you for noticing that. So this point here is okay, except this is negative 2, yes?
Yes.
Okay, good. All right, are you okay with the shape? Okay, good. So you get 1 mark for the shape, you'll get 1 mark for the asymptotes, and you'll get 1 mark for the turning point and also the intercept. Yes?
So yeah, we would need to also say y equals 0, right?
Absolutely, absolutely. And that's what a lot of students forgot with that one. So we've got y equals 0, we've got x equals negative 3, positive 3, we've got 3 asymptotes, and maybe they would, yeah, I'd say they give you 1 mark for all the asymptotes correct. If you're missing an asymptote, you lose a mark. 1 mark for, it says clearly indicating the location of any asymptotes and intercepts with the axes. So I would say that let's do this in coordinates, 0, negative 2, and yeah, that's about it. All right, so far, hopefully so good. Let's go through though, and I'm going to have a go through this question. Now this question was poorly done. It's worth 5 marks. Now it says here, sketch the graph of y equals 2 on x squared minus x on 2. Now, first of all, let's have I'll just get you to pause it. Can I get a show of hands of students that have already attempted this? Okay, good. So that's most of you. So I'm going to go through it now then. All right. Now, first of all, when we sketch 2 graphs, you can use addition of ordinates. It's going to give you an idea of the shape. Now, if I've got a graph of 2 on x squared, oops, what's going on? If I've got a graph of 2 on x squared, and I'm adding a negative x on 2 graph, if you like, we can sketch that, get an idea of the shape with addition of ordinates. And that's the whole point of this. But it says give the exact coordinates of the turning points, intercepts, yada, 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 asymptotes. First of all, let's identify the asymptotes. What's the most obvious asymptote? Asymptote at x equals 0?
Yes.
X equals 0? Yeah, okay, so because obviously we can't, that would be undefined. Now, if this expression here can't be equal to 0, okay, because that means x can't be equal to 0, then therefore that there's going to be an asymptote at minus x on 2, isn't there? Just a straight line asymptote. Now, there's not going to be an asymptote on 2 on x squared, but we can use that as in addition of ordinates. So we've got an asymptote at x equals 0. We've also got an asymptote at negative a half x, if you like. Are there any other asymptotes? No. Okay, good. Now let's sketch those for starters. So let's go, I'm going to just put those down as we've got an asymptote at x equals 0, and you've got an asymptote at negative a half x. Be careful though, they've given you a scale. So negative a half x. So if I was to go over, I've got a gradient of rise over run. So for every 2 we go across, we go like there, 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 and there. So make sure you get that right. And label it, please. Oops. So we've got y is equal to negative a half x. So there are our two asymptotes. Now what we need to do is we need to find any intercepts. So, but with addition of ordinates, if you think about it, we will know what intercepts there are, because let's think about a 2 on x squared graph. Now a 2 on x squared graph, but the problem is we've got to get the right, at x equals say negative 1, that's going to be equal to 2. So we'd have like something like this, but you've got to be careful. So we've got a graph like this, okay, that's been dilated. And then we've got a graph of negative x on 2, sort of goes like this. Now if I'm adding those ordinates, if you think about it, this ordinate here would sort of be doubled and will go sort of up here. This would sort of go towards this line here, and it looks something like this. But what about adding the ordinates here? You've got infinity, and then you've got this side. We're definitely approaching from infinity. But then over, as you come through here, you're going to have, so this general shape is sort of what we're looking at using addition of ordinates. We're going to have something like that. Now what can you tell me about, is there going to be a y-intercept looking at that? There's not. So what we need to do is don't bother finding a y-intercept or anything. Let's just go ahead and find the x-intercept. So the x-intercept, and we know that there's only going to be one x-intercept just by looking at that graph. So that's what we've done with addition of ordinates. And let x-intercept, let y equal to 0. And we now need to go, so 0 is equal to, I'm just going to say x on 2. X on 2 is equal to 2 on x squared. And x cubed is equal to 4. Therefore, x is equal to the cube root of 4. Now, we'll just leave it as that. Okay, so we've now know that the cube root of 4, well, what is the cube root of 4 roughly, do you think? 1.5 something. So we're going to have our intercept there. Now, be careful when sketching this graph. You might want to do something like this and sort of get an idea. At negative 2, that's going to be negative 1. Okay, so we're basically going to have this graph here. Okay, and then obviously equal on the other side. Oh, negative 2, yeah, that's something like that. And then we're adding the ordinates of those. So we've got the shape down pat now. But the thing is that we need to find, before we go ahead and add it there, we've only got that in grey lead just for an idea now. What we want to do is we want to find the turning point. So we know that the turning point occurs when dy dx is equal to 0, isn't it? So therefore, with dy dx, let's find out what that is. It's just a sort of a straight polynomial. We've got minus 4. Is that minus 4 on x cubed? Is that right? X to the minus 2. Drop the power. Yep. Minus a half. And then therefore, that is equal to 0. And we're going to say that a half is equal to negative 4 on x cubed. Therefore, x cubed is equal to negative 8. Therefore, x is equal to negative 2. And then when x is equal to negative 2, y is equal to, I think it was 3 on 2. Is that right? Yeah. Okay. So, we've now found this coordinate here. I don't see any problem with us now drawing that graph in, and we've got x equals negative 2, y equals 3 on 2. So there you go. There's our turning point. Okay? And then you've got it coming through here, and get a rough sketch of it, but as long as we start up here, there's definitely an asymptote, and it's then approaching, say, this point here. That's not a very good sketch, but you would do a better job than me, wouldn't you? And we need to now state the coordinate. Does it say give the exact coordinates? So we've got to be careful with this question. of any turning points and so on. So what I would do is I would just say, okay, that's -2, that's 3 on 2. I'll sort of put a little arrow there if you like. I've got the coordinates of the asymptotes, that's okay. This point here, and I've shown with working as well, that was the cube root of 4, 0. And is there anything else? I think that's about it. How do you think the marking would go? What do you think, Luke? How do you think the marks would go with this?
So there's 5 marks.
There's 5 marks, good.
Alright, so probably 1 mark for the 2 asymptotes.
1 mark for the 2 asymptotes, yep.
2 marks, 1 mark for your working and for the coordinates of the turning point.
Yep.
Another one for the intercept.
Yep.
Another one for the shape.
And that would be it, wouldn't it?
There's like 5 marks though. So.
Yeah. Yep. So that's how I would guess. This question was pretty poorly done though. Did you any of you check out their examiner reports? And look, this is the thing. Like I didn't want to rush through this because this is like one of the most poorly done things. If I go to now, I'll just have to I might just pause it just for a moment, and I'll go find the examiner report and. All right. So for this question, it was fairly poorly done for quite a simple question, which used addition of ordinates, a simple derivative, and finding an x-intercept. So many students were able to find the equations, the asymptotes. Many were able to find the x-intercept, and many were able to find the turning point. But few were able to complete all of these successfully. Often the thing is, if you're not drawing asymptotic behaviour, then you would lose marks for the shape. So that's really important as well. But that question was sort of done pretty poorly. But not many students got full marks, less than 20%. All right, so I'm going to pause this video and I'm going to go through the next question. All right, so have a go at this question now. If you're watching this at home again, then pause the video, give yourself about 4 or 5 minutes to try this question. So I'm going to resume. So first of all, with this question here, pretty straightforward. What I said is that 2x squared plus 3 on x squared plus 1 is equal to 2x squared plus 2 on x squared plus 1 plus 1 on x squared plus 1, and which is equal to 2 outside of x squared plus 1 over x squared plus 1 plus 1 on x squared plus 1, which is equal to 2 plus 1 on x squared plus, oops, here we go again, my favourite thing that always happens, on x squared plus 1 as required. Okay, so now we've got this. What you need to identify is we've got the graph of 1 on x squared plus 1. Now let's draw x squared plus 1 just to get an idea of what we're looking at. Because x squared plus 1 is going to look something like this. Now you, of course, don't really do this. You could do it in grey letter if you like. But the graph of the reciprocal of that is 1 on x squared plus 1 is going to be what? It's going to look something like what? What's it going to look like? Huh? A hump. Yeah? Is it a hump going this way? No, it's not. Because isn't it a 1 on x squared graph? Isn't it going to look something like, is it going to look something like this? Let's think about these values. What are the values here, the y values? They're positive, aren't they? So it's going to be 1 on a very, very big number is going to be a small number. 1 on a very, very big number is also going to be a small number. So this is the graph of y, equals 1 on x squared plus 1. This here. But what do we have to then do? We have to apply, and there's an asymptote at y equals 0. But then what are we doing? We're actually moving that graph up too. So therefore, so we can do this by just applying our reflections, dilations, translations, all that sort of business. So so what happens is that this turning point also moves up too. So we've got an asymptote at y is equal to 2. This is our shape. It clearly is a turning point at that point there. And that is equal to, so I'm just going to draw it in blue now. This is what you guys should have, sort of like that. It's probably not so bumpy like that. I think that's not a very good graph either. So I'm going to do that again. All right, so we've got this. And let's sort of... It's clearly a turning point. And we've got the point 0, 3, and we've got that. So once again, you get 1 for the shape, you get 1 for this turning point, and you get 1 for the asymptote. All right. I'm going to pause the video and give you another question. All right, so my thinking with this question is, first of all, we have asymptotes at x equals 4 and x equals minus 2. So instantly, that cuts out A, B, and C. Now, it's out of D and E, but what we're going to say is that if I've got my graph or my reciprocal graph, I've got an intercept at -2 and 4, which means that the turning point is at 1. Now, that's not going to really help us because we've got two options there. But at x equals 1, f of x is equal to 1 over... Sorry, at x equals 1... We've got -3 times 3. F of x is equal to -1/9. So, therefore, the answer must be E. 30 seconds. That's pretty much all that is. All right, I'm going to find another question for you, and we'll pause it. We've done that one. Let's have a look at this question here. So, if you're at home, pause this now and have a go at this. I'll give you a couple of minutes, but this question really... Once again, we've got to go through each one and probably just rule them out one at a time. I'm going to pause it now. You guys have a go. I'm going to give you 2 minutes of this one. All right, so really quickly, first of all, you can see here that we've got an asymptote at y equals x squared. So that's going to rule that out because 2x to the power of 4 on x squared is equal to 2x squared. So that obviously rules that out. Now, what I'm going to think about this is doing an addition of ordinates and just having a look one at a time. X squared plus a on x, such as a is greater than 0, is going to be a graph which looks like this, and we're going to add the ordinates of a negative. That's not going to be it. Okay, so that just rules that out instantly, because if I've got these graphs added, then I'm going to be somewhere below this line. So that's clearly not the case. What about over here? If I've got this graph over here, it could certainly be B, but at the same time, if I looking over here, A is less than 0. Okay, so A is less than 0. That means that we're going to have that and that. We're going to be below the line again over here. So it's not this one either. So it's out of D or E. And over here, we've got an x squared graph. 1 on x squared, or -1 on x squared, is going to look like this. If I add in the ordinates of that, then we're going to be below that x squared. So therefore, it just has to be D. Okay, so just addition of ordinates is the best way to do that. Okay, and it shouldn't take you that long. Now let's go ahead and let's not do that one. We'll do that for another time. There you go. Let's have a go at this one, please. I'm going to pause the video and give you 2 minutes to... let's do question 1. All right, I've just started it again. First of all, x can't equal 0. That's one asymptote. So that's x is equal to 0 as an asymptote. And if x can't equal 0, then that means f of x can't equal 2x either. So therefore, you've got an asymptote of 2x. Y is equal to 2x. So it's got 2 asymptotes. So therefore, we rule out those ones, and it has to be C, D, or E. Now what we need to do is let's sketch the graph of -1 on x squared. Now we know that x squared looks like so. So therefore, -1 on x squared is going to look like what? A truncus? Yeah? An upside down truncus. Is it going to be looking something like what? Like this, or what is it?
No, it's going to go down with an asymptote at x equals 0.
Asymptote at x equals 0. Okay, so we're looking at what? Say something like this?
Yeah.
Yeah?
Yeah.
Okay, excellent. Good. So if they've got... So what can you then tell me? We've got a local maximum or a local minimum. What have we got? Have we got a maximum or a minimum? A maximum. So does that rule out D? Okay. So we now need to decide which one is it. How do we work out the point of the local maximum?
We see where
Okay, good. So let's just do that. The derivative of that is 2 plus 2 on x cubed, isn't it? And we let that equal 0. You don't have to do that in your calculator. You could just solve that if you like, but if you then, you can say that minus 2 on x cubed is equal to 2. X cubed is equal to negative 1. So therefore x is equal to negative 1. Therefore the answer is E. Yes. Would you agree? Yes. Okay, not too bad. What about question 11? I'm just going to pause the video and get you to have a bit of a think about this. But let's think of, this is one of those ones where you have to rule out each option, I think. So I'm going to pause this video, have a go at this one, question 11. Right, so this one is actually a pretty straightforward question, but students didn't do too well on this either. First of all, we know that this graph is increasing. So therefore, we've automatically ruled out B and D. We've now got options A, C or E, but it says here having a non-stationary point of inflection, f double dash of x would have to be equal to 0 at a point of inflection. So it's now A or C. And if you think about it, we've got an increasing gradient or a decreasing gradient. Well, a decreasing gradient comes with an f double dash of x. So therefore the answer is C. Pretty easy question. That one, once again, you could do that in under a minute. You should be able to do it in under a minute if you're on your A game. All right, well, I'm going to stop that video there. I hope you've now learnt a little bit more about how to do addition of ordinates in exam questions, how to sketch a graph, how to do reciprocal functions, and by sketching out the reciprocal function in grey lead or something on your exam helps you actually get an idea of what it looks like. All right, so I'm going to stop there. And, oops, no, we're going to stop there.